Hello, everyone. Thank you all very much for coming today. So my name is Yuta Numoto. Today, I'd like to talk about reinforcement learning. So my talk title is Unity Reinforcement Learning for Everyone. And the easiest way to make your first AI laboratory with Unity ML agent. So let's get started. So how do you feel when you hear machine reinforcement learning? So some of you may think, oh, it's for me. That's nice. And some of you may feel it's not related to me. But don't worry, I will talk about what it is shortly. And our main theme today, Unity ML Agents, is for both of you. So it's an easy tool that you can make your own AI laboratory. Sounds nice, right? So let's see today's agenda. So first, I talk about what's Unity, and next, what's Unity ML Agents, then brief introduction to artificial intelligence, and let's make preset agent work. And let's create our new agent. Finally, application to real game and how to get started. Okay, by the way, who am I? I think you are wondering. So let me introduce myself briefly. So my name is Yuta Numoto again. So I major law and political science at the university in Tokyo. After graduation, I worked in a Japanese industrial electronics manufacturer and experienced three totally different roles. So first was sales and marketing of the innovative lithium-ion battery. So our products are on these electric car or eco-friendly cars like Mitsubishi and Honda's 100% electric cars and energy charge system, which is on almost every car by Suzuki. And next is the new business development of plant factory, which our company had started business as a truly new business. So it's vegetables growing in a clean room with just fluorescent light and pure water. So we don't have to wash the vegetable even once before we eat, so we could feel the real taste of vegetable, which we cannot taste nowhere else. So lastly, I handle the international trade business, especially for the thermal power generation facilities. I was mainly in charge of handling the business in the United States, and this is almost the same product we provided to the utility companies. It is very huge and sometimes take more than a year to make. Then why I'm at Code Chrysalis right now. So this is because of my inner motivation. So I like something new, innovative thing that can give users delightfulness and surprise, delivering new value. So that's why I chose my previous company and projects. And I highly appreciate it that I could work for those diverse categories of projects. But I noticed that I could only work for business parts like this. So I want to create an innovative thing by myself. So I want to pursue the career in the intersection of business and design and engineering. And I finally realized that this intersection is a software engineer. That's the reason I quitted my previous job and joined Code Chrysalis and now speaking in front of you. So let's see today's agenda again. So next topic is what's Unity? Okay. So Unity is a game engine for everyone. Democratizing game development is the word by founder of Unity, David Helgason from the United States. So this means Unity is aiming for the realization of the open world where everyone can start making games. That's nice. So before Unity, each game companies had individual hidden game engine like this. So these are each individual game companies. And this means these technologies cannot interact each other. And engineer also can communicate or change companies each other. So it was very inefficient. After Unity, it unified literally all the game development environment. So since then, Unity is said to have dominated 50% share in mobile 3D game, and 3 billion devices using Unity around the world. So according to the market report, smartphone games market is about $64 billion. So it's very huge. Okay, so let's move on to the next. So next is what's Unity ML agents? Okay, so its full name is the Unity Machine Learning Agents Toolkit. So it's a plugin for making learning environment for reinforcement learning, and it unites Unity environment with Python scripts for running. And it has more than 15 preset examples. And you can use this toolkit without deep knowledge of machine learning. And its first release was 2017, and its latest release is almost 2 weeks ago this month. So, and as you can see, it updates so frequently that you have 6 updates in 100 days. So you can tell how enthusiastic the developer and community is. Okay. And its mission is allow game developers and AI researchers alike to use Unity as a platform to train and embed intelligent agents using the latest advancement in machine learning. It sounds perfect, right? So next is brief introduction to artificial intelligence. So what's the difference of these terminologies like artificial intelligence, machine learning, reinforcement learning, deep learning? So there are so many terms related to learning. But don't be afraid. Let's digest one by one. So what's the difference? Let's think about a box representing whole artificial intelligence category. So there are 2 categories in the AI, rule-based and machine learning. The brain of rule-based AI is written by man, and they are if-then type. The AI utilizes the rule to make inference. On the other hand, machine learning utilizes data and algorithm to make inference, meaning there's no rule made by man. In these 2 cases, only rule-based AI has limitation of intelligence by man's reasoning. In machine learning, there are 4 types of learning. First is supervised learning, and then unsupervised learning, reinforcement learning, and deep learning. So today's main topic is, of course, reinforcement learning. So let's dive into this. Okay, so what's the reinforcement learning? So in short, it's a way to run a better action from experience. And okay, so like babies trying to walk by themselves, like this. So what's the reinforcement learning? For example, here's an entity called agent. Agent is an entity which will act and learn in a certain place like this. And this virtual place is called environment. Environment always has its certain state. As, for example, this chocolate is a state. Agent sees the state and decide what action to take. This probability that the agent will take action A is in a certain state S is called policy. then the environment will return the reward or punishment depending on the action. This reward is called immediate reward. So there is another reward called accumulated reward, which the agent will get in the future as a result of actions. So the purpose of the reinforcement learning is maximizing accumulated reward. So sometimes there are conflicts between immediate reward and accumulated reward. For example, if you eat chocolate, that's good for your immediate joy, but it's obviously not good for your long-term wellness, right? So basically, what agent has to do is improving its policy, which is the probability the agent will take certain action from try and error so that the agent's long-term reward is maximized. Okay. So now that we understand what reinforcement learning is, so let's dive into the sample demo. ML Agents has many presets that you can play with after installation. So today, let's have a quick look for 3D ball at the top left. This one. Okay. So I think you can see the demo screen. And here you can see 12 agents, and its mission is to control the ball on top of their heads. So it means they shouldn't drop the ball. Okay, so let's play first manually. So in order to do that, let's show the keyboard here. Okay. So they don't have any policy or brain right now, so they don't work automatically. So we have to control. So, but they work synchronously. So let's see just the top leftmost one. So like this, if I push the cursor, it will tilt sometime. But as you can see, it's very difficult to keep the ball just top of the head because it's very sensitive. So I have to push the cursor so many times. Okay. But when we apply the brain or policy like this, and let's change the view. Okay, this time, they now get the brain or policy, so they don't drop the ball anymore. And as you can see, it is working so hard not to drop the ball from their head. So, and you can see it frequently moves like I did by my keyboard, but now they are just doing by themselves. Okay. So let's go back to the slide. So next is our term. So let's make our original entity and make it learn. So when preparing our agent, there are two ways. First is creating our own 3D model from scratch using software other than Unity. Or the other way is utilize 3D model assets Unity has. Because creating 3D model is not today's theme, let's go utilize asset paths. Okay. So today I'm going to use Unity official free asset. So it's called Unity-chan, and it's the original character made by Unity itself. Okay. So we can utilize this 3D model if we show license or character logo like this. Then let's go to the demo. So here you can see the entity here and target box here and field here. The purpose of the agent here is to chase and touch the box wherever the box appears. So first, let's make the agent run from 0. So right now it don't have any policy, and we can start running just using this console. So let's run. it takes some time to start. Okay, so when this Unity logo appears, it means we are ready. So let's push start. And when it starts, the console shows the current status of running, and you can see how the agent is working right now here. But as you can see, it works very awkwardly, right? So the purpose is just go straight to the box, but it seems it doesn't know what to do or just it kill itself. So it's very weird. Just because it has no brain right now and it doesn't know what to do. So it's just doing try and error so many times. So which way to move or what to do. So, okay, let's stop this because it takes time to complete. And so we have already learned brains here. So let's apply the 100 try and error brain here. And let's just change the speed. Okay. This time you can see the 100 times run computer brain. Okay, but still it works very awkwardly, right? It doesn't recognize the box or it still kills itself. Okay, then let's move forward time. So 50,000. No, 5,000. So this time it looks a little bit better, I think. It can sometimes touch the target, but apparently it still need more time to get used to this activity. Okay, so let's next is 50,000 model. So actually 50,000 times is enough for human, or we can even do that same thing 50,000 times, right? But for the computer, yeah, it might be enough. So we can see much improvement here, but it's not so totally straight, right? So sometimes it still moves awkwardly or not so straight. So finally, let's apply the 500,000 model. So of course, we humans can do the same thing 500,000 times, but computer can do. And it's, yeah, enough for computer as well, right? As you can see, this time it chases the box very well. And yeah, it's like hunter chasing the horse or something, right? So, okay, let's stop this. Okay, so the next and final section is application to real game and how to get started. So now that we understand how agent will become cleverer, let's see the real use case. So here is a simple but real application of ML agent to the game. It's called Puppo. So let's see the demo movie. So here, when user threw a branch to the dog, it can get the branch to the user. So he is trained using ML agent to be able to walk, run, jump, and get the branch. At first, like Unity Jam, the dog didn't know what to do and even can't walk properly. But after many times of practice, it became such smarter, like the real dog, right? Okay. So let's go to the next. So if you are interested in this technology, using the following documents, you can play with ML Agent from today. I have 3 recommendations. First is a Unity official site. he has many articles explaining what you can do with ML agents. Those are helpful. So second is official GitHub documentation. It's a very decent guide that you can make your laboratory following the step-by-step explanation. So it's already so popular among developers, like it has 9,000 stars. Okay. And finally, I recommend this article. This is kind of the translation of official tutorial, but its flow is easy to follow and especially useful for Japanese speakers. And this can be applied to Mac as well, though it states Windows 10. Okay. So that brings me to the end of my presentation. So thank you for your attention. So this was presented by Yuta Numoto, and these are my GitHub and LinkedIn link. So if you are interested, please feel free to contact me anytime, anywhere. So it was a pleasure being here today. Thank you.